Okay, it's about time to get started. Can I just get a smiley face if you can hear me okay? Great. Okay, I'm on the West Coast this week, so it's a little early for me. I see how it might be a problem for some of you on the West Coast to get to some of our sessions now. So let's start out and see if there are any questions on any of the material that we've been covering, and then we're going to try to do a problem together to practice a little bit more with cumulative incidence and prevalence. I think people need a lot of practice with those to get them right, so we'll work on a problem together, but first let's start and see if there are any questions. Okay, just a couple of administrative items. I'm going to be posting the midterm practice exam this weekend. It's not something that you need to turn in, but it is pretty much exactly like what the midterm is going to look like. We've covered most of the material to do almost all of the problems. There are a few that you won't be able to do yet, but I would encourage you to go ahead and try to start doing that so you'll be ready to start the midterm when I post it a little bit later. A reminder that for the midterm, it's not time limited at all. You have as much time as you want. Oh, and I forgot to turn on your mics and chats. So your mics and chats are turned on now if you have questions. Sorry about that. The midterm is not time limited. You have as much time as you want to do it. It's going to be like the practice where I'm going to post a Word document that has all the questions. You can go off and spend as much time as you want working on that and then come back and put your answers into the Blackboard test whenever you're ready. So now that your chats and mics are on, let me double check and see if there are any questions. Okay. I'm going to start application sharing. Nisarg, go ahead. Oh, hold on, Nisarg. My volume's turned off.
Hi. Can you hear me?
Go ahead, Nisarg.
My question is that like a Blackboard quiz or is like a open-ended questions on the test?
There'll be a few multiple choice questions, but for the most part, they're short answer and will be almost exactly like what we're going to do tonight and what's on the practice exam.
Thank you.
Sure. Okay, so what we did on Tuesday was instead of me giving a problem for you guys to work on, I actually let you guys I let the students come up with their own problem so that, excuse me, we can make sure that we're practicing all the things that you want to practice, things like accounting for people who are vaccinated, accounting for people who maybe died somewhere along the way or were lost to follow-up. So I'm going to give you guys a choice of either coming up with your own problem, and I'll just type it in as we go along, or we can use the one that the students on Tuesday came up with. So your choice, just let me know what you want to do. We can use that problem, which was a Zika problem. We did Zika disease in a couple of different populations, or you can come up with your own. What would you guys like to do? Okay, the Sark says measles, so sorry, would like to do measles. I'm not seeing anything else, so I'm good with that. So we're going to need a couple of different populations to follow up. So let's say we're doing a study in one population where we're testing out some infection control interventions to stop the spread of measles, and we're comparing it to a group without the infection control procedures. So let's start with our first group of 100. Huh. I cannot see what I'm typing. Give me 1 second. Can you guys all see the document okay? There we go. Okay, so we've got a group of 100. So let's start talking about, sort of our special cases, people who had disease at the beginning, people who were vaccinated, and then we'll talk about people who developed disease or were lost to follow-up along the way. So you guys just tell me what you want in there, and I'll start typing them in. So think about the kinds of things that may have been giving you trouble along the way, dealing with vaccinated or disease at the beginning, and let's make sure that we have all of them in. So Michael said 3 people had measles at the beginning of the study. Okay. Okay. What else would you like in there? 5 were vaccinated already, and 2 were vaccinated in February. Okay. What else? You can raise your hand and talk to if you don't want to type it in. So one of the ones who was vaccinated died in March. Okay. And Michael, what did you want them? Oh, from February. Okay. And Michael, what did you want that person to die from? let's say unrelated causes from a car crash. Okay, 4 were lost to follow-up in May. Okay, let's get a couple more cases of measles in there. Two developed measles on March 1st. Two more were vaccinated in July. Okay, how about one more case of measles? Let's say October 1st. Okay, do we have all the types of people that you want in this group to make sure that we answer all your types of questions? Pardis, go ahead.
Can we also say if some people who were vaccinated, maybe they also died? I mean,
okay, we actually have
but they were exposed.
Yeah, so we have one. We have one like that already.
Oh, okay, the one in the car crash?
Yeah.
Okay, thanks.
Okay. Okay, and I'm just going to put up here, assume vaccination is 100% effective on first day of vaccination. Okay. Okay, I think that's good. So let's start drawing out our diagram. Oh, good point. Let's talk about how long they had measles. So the two who developed measles on March 1st were cleared on April 1st. And how about the 3 who developed disease at the beginning, who had disease at the beginning of the study? So let's say they were free of disease on 2 were free of disease on February 1, and 1 was free of disease on March 1. And the October 1 will say still had disease at the end of the study. So Nasarg, I think we'll answer that question as we go along. So we're going to assume that you can only get measles once. So they are no longer at risk once they develop disease. Okay, so let's start drawing out our chart. So I'm going to use yellow for the time that they had disease. I'm going to use V for vaccinated, L for lost to follow-up, and D for died. And so we have 3 who had measles at the beginning of the study, 2 that were free of disease by February 1st. So they just have 1 month in yellow. And the third one had disease for 2 months. So everyone okay with how I drew those first 3 people? Okay, great. So now we had 5 individuals who were determined to be vaccinated at the beginning of the study. So I'm just going to put a V on January 1st. Then 2 were vaccinated on March 1st. And 1 of them died. Oh no, they were vaccinated on February 1st. And 1 of them died from a car crash. On March 1st. And then 4 were lost to follow-up on May 1st. And then 2 developed disease on March 1st and were free of disease on April 1st. Two were vaccinated on, we'll call that July 1st. And 1 more developed disease on October 1st. And still had disease at the end of the study. Okay, did I get everyone? Let's go through. So we had 3 that developed disease at the beginning. 1 for 1 month, 1 for 2. 5 that were vaccinated. 2 more vaccinated in February. 1 dies. 4 lost to follow-up on March 1st. 2 disease on March 1st. So, sorry, lost to follow-up on May 1st. 2 March 1st to April 1st with disease. 2 were vaccinated on July 1st. And 1 with measles on October 1st. Yeah, Pardis.
Sorry, my number 18 for me was green, and I thought like it's a different color, but now it's yellow.
Oh, okay. I'm not sure why that was,
Thanks.
but okay. Okay. So let's go through and talk about the amount of person time that each of these contributed. So let's do the first two people. They're the same. They had disease at the beginning and were free February 1st. How much person time did they contribute? Yep, I see 0 in the chat. Luna, do you agree with that? And what about the other one that had disease on January 1st and was clear on March 1st? So I see a 2, but does someone who said 0 want to tell us why it's still 0? Yeah, Luna, go ahead.
So basically they had the disease when they first got it, so they're not at risk to developing disease after. They had the measles.
Yep. So they had disease at the beginning of the study, so they were never at risk, so it's 0. So how about our 5 who were vaccinated at the beginning of the study? Yep, they're all 0 as well for the same reason. So we said our vaccine was effective from the beginning. Then how about our person who was vaccinated February 1st and died March 1st? That's right, that's 1. And our person who was just vaccinated on February 1st? Yep, that's 1 month also. Our 4 who were lost to follow-up on May 1st. Yep, I see lots of 4s, that's right. Then we had 2 who developed disease on March 1st. Or cleared April 1st, that's 2. We had 2 more vaccinated July 1st. That's right, there's 6. And finally, our person who developed disease on October 1st. Yep, 9. And then, so we've talked about 19 people. So for the rest of the 100, how many person months did they all contribute? Oh, yes, 18 should be 6. Thank you. That's why for the midterm, I recommend that you do it once, let it set for a couple of days, and come back and check your answers. So, yeah, I don't think it's 79. It's 81, right, Marion? Yeah, you corrected yourself. So we had 100 less than 19, all for 12 months, so that's 972. And then we want to get our total, and for the total, I'm just going to sum up all of these. So 1,015 person months total. Everyone good so far? Okay, let's do cumulative incidence first. What's the formula for cumulative incidence? A over A plus smiley face. Okay. A over A plus B. Yeah, if we had drawn our 2x2 table out so far, then that's one way of writing it. What's a way of just kind of saying it in English? I'm sorry, I think you said to call you something else, but go ahead. Don't forget to turn your mic on.
Can you hear me?
Yes,
yeah,
I can hear you.
My name is Shegon. Just call me Shegon. Okay. Yeah,
Shegon,
I'm not trying
right.
to take you back, but how did you come across this 972? But I'm kind of lost.
Okay, sure. Great question. Thank you, Shegon, for asking that. So, we talked about 19 people, right? So we have persons number 1 through 19 that we knew some specific information about. And then we know that we had 100 groups, 100 people total that we're following, because in the beginning I said that we were following a group of 100 individuals. So all of the rest of the people that we didn't talk about, they never got vaccinated, they were never lost to follow-up, they never developed disease. So they were all at risk the entire 12 months. So the rest of the people, which was 81, because we talked about 19, so that left 81. So they all contributed 12 person months. So 972 is just 81 times 12 person months each.
Okay.
Did that answer your question?
Yeah.
Okay, thanks for asking that. That's one that people sometimes get stuck on. So
thank you.
Okay, so I see a couple of people who put in an answer for cumulative incidence. So I see it's patients who develop disease divided by patients at risk, new cases divided by total people at risk. It's not really exposed divided by total population. So Michael and Luna, I would say, together you're really close. So Luna, I assume by developed measles you mean new cases. For me, I always like to put the word new when I kind of write it out in words. And it's the total people at risk. I always like to remind myself at the beginning of the study, so I like to write that out when I write the formula, just so I remember that and don't do anything wrong. So CI equals number of new cases divided by total population at risk at the beginning. So I think Michael has already helped us out and said that there were 3 new cases and the number of individuals at risk is 100 minus 8. So Michael, I think your mic works. Can you tell us how you got those numbers so everyone can follow along? Yes.
Okay. So we got 2 new cases in March and 1 more in October. So that's my 3 new cases. And we started with 100, but we have to deduct the first 3 who already got measles and the 5 that already got vaccinated at the start of the whole thing. So
that's exactly right. So we don't count the first 3 cases, the first 3 people as new cases, because they came in with disease. So it's persons number 15, 16, and 19 are the only 3 new cases. And then the 3 individuals who came in with disease and the 5 individuals who were vaccinated were not at risk. So we have to subtract all of them out. So that's how Michael got 3 out of 98, which is exactly right. So if we let Excel calculate that out, it's 0.0306. You can express that as a percentage as 3.06. So you want to always write out a sentence for your answer for these, because that's what I'm looking for on the midterm is your sentence. So the CI of measles in the group with infection control practices is 3.06% during the study period. And I just heard a question. Pardis, yes, what's your question?
So the total population at risk, Michael said it's 100 minus 8, right?
Yeah, I made a mistake. You're right.
Oh, okay, thanks.
92. And I should have written it out like he did, as 100 minus 8, and then I would not have made that mistake. So that makes it 3.26%. Great, thanks for catching that. I'm going to pretend like I did it on purpose so that you guys know how to catch errors, but that's an important part of this, is going back and checking it and seeing where you may have made a mistake. Okay, let's do the incidence density now. So what's the formula for incidence density? Just in words. The number of new cases divided by the total person time, okay. Total person time at risk. So how many new cases were there? Yep, it's still 3, just like it was for cumulative incidence. And what's our total person time at risk? Yeah, 1,015. Let's do 3 over 1,015. Then I'll let Excel do that. And I'm going to go ahead and multiply my answer by 100,000. So I can express that in per 100,000 person months. So the ID of measles in the group with ICP is 296 per 100,000 person months of follow-up. During the study period. Okay, let's do a couple of prevalence problems now. So I'm going to I'll post this, Michael, and the first sheet of this has the Zika example from the other class, so you can actually see them both if you want to go back and listen to that too. Yeah, the Zika one's posted, but I'll post this one too. Okay, so I'm going to let you guys pick a couple of dates for prevalence. So think about, what gives you problems when you're calculating prevalence. Is it lost follow-ups, vaccinated? What gives you issues? And let's pick some dates that might be tricky. Okay, April what? April 14th. Okay. Let's do that one first. So what I like to do is draw a line on that date. It's kind of in the middle of the month there. So what's our formula in words for prevalence? Existing cases divided by population. I like to be a little more specific. And what I like to say, Muna, is existing cases on April 14th divided by total population on 4/14. So, how many existing cases are there on April 14th? Yeah, there's 0. And what is our total population on April 14th? 99. That is right. So, the prevalence of measles in the ICP group on 6/14 is 0%. So I'm glad you guys actually did this one, because it brings up an important point. On the midterm, yeah, and it's because of the one who died on 3/1 that it's 99. That's right. But this is kind of what I want to see on your midterm is tell me what the formula is in words. Show me how you substituted into it. Here, 0/99, what your answer is, and then your answer in words. So all of this is what I want to see on the midterm. Because if you just tell me the prevalence of measles is 0%, I'm not going to know that you really got that from 0/99. So you want to show me all your steps. And that way, too, if you get it partially right, you can get partial credit, too. So, what's another day that you want to do? November 10th? Okay. So same thing, prevalence equals number existing cases on 11/10 divided by total population on 11/10. So how many existing cases are there on 11/10? There is 1. And what is our total population on 11/10? 95, because we had 1 who died and 4 that were lost to follow-up. So Peter, do you see why it's not 99? Great. So P equals 1 divided by 95. So the prevalence of measles in the ICP group on 1110 is 1.05%. Okay. So let's do another group so that we can do some measures of association. And we're not going to do the whole chart for this next group. We're going to have in another group, we follow 100 individuals in a population where infection control procedures are not followed. So, let's come up with some numbers for this one. So let's go through the same thing. Just tell me what you want to see in this group. Disease or vaccinated at the beginning, and then some new cases along the way. Oh, infection control practices. So we're just comparing two groups to see how well the advanced infection control practices work. So we have one group where we've got infection control practices and another group where we don't. And we're seeing if, as an intervention, how effective that is. Okay, so while you guys are thinking about this group, I'm going to make up a couple of things. So we're going to say 2 had measles at the beginning of the study. 3 were determined to be vaccinated at the beginning of the study. I'm going to go ahead and say 1. I'm not going to do that. So let's come up with some new cases and some loss to follow-ups. I don't I don't want to say that they didn't gain immunity. So, and you got to tell me the dates, Marion, for that. Five lost to follow up on 4. We'll use 4-1. Okay. Let's have some new cases. Five got measles on June 1. So we were clear on August 1. Okay. Let's do a couple more. 10 new cases on 10-1. Oh, yeah, because they went out and went to school. And that's part of, I think, what the infection control practices would be. So what is that? 10 on 10-1. Okay. 2 got measles on August 1st, and one of those died on November 1st. Okay, so I think that's good, and we're not going to do the chart and calculate incidence density for this one because I think you guys are really good at that. We're just going to use this information to calculate a measure of association using cumulative incidence. So we're going to calculate the relative risk using CI. So in order to do that, we need to draw our 2x2 table. So I'm actually going to I figured out how to put a nice table in here that's easy. So we've got our ICP group. No, I don't want to do it that way. And our no ICP group. And then we had those with measles, those without measles, and the total population at risk. So going back to our ICP group, we want to fill in these numbers in the 2x2 table. So how many new cases of measles were there in our ICP group? No, in the first group, in the group that had ICP. Yeah, there were 3. And what was the total population in that group? I don't think it was 99. Yeah, it was 92. So you had 3 and 92. So how many was that with no measles? $89. And then in our no ICP group, which is this one down here, how many new cases were there? Yeah, it looks like 15. And what was our total population at risk for that one? So Tracy asked how we got 15. So does someone want to tell Tracy how we got 15 new cases of measles for our no ICP group? Go ahead, Muna.
So technically, because 5 people got measles on June 1st, and then 10 got measles on October 1st, that would be a total of 15 new cases.
Yeah, and don't count the 2 at the beginning of the study. Did that answer your question, Tracy?
I thought 2 also got measles on August 1st and 1 died on August 1st.
Oh, do I have that here?
Oh, maybe you deleted. I don't know. For some reason, I have that.
Oh no, I maybe someone put that in the chat, but I didn't put that into the problem.
Okay, yeah. If that's the case, then yeah, I also got 15. Yes.
Okay, great. Okay, and then what's our total population? Oh, we got our 95 for our total population. So how many was that with no measles? And then for some of the calculations that we do, you want to have totals. So you can just let Excel do that for you. So, if we're going to do relative risk now, we can say it's the CI and the exposed divided by the CI and the unexposed, or sorry, yeah, the CI and the exposed divided by the CI and the unexposed. We could also use the A and B terminology here if you wanted to. So you could say A over A plus B divided by C over C plus B, but let's just substitute in the numbers for the relative risk. So what is the CI and the ICP group, the exposed group? 3 over 92. Yep. Pardis, did you have a question?
No, I'm sorry. I was just going to say 3 over 96.
Okay, since you're on, what's the CI and the exposed group, or the the no ICP group?
15 over 95.
Yep. So it's important that you put in those parentheses so that you actually calculate this out correctly. And I'll just let Excel do that. So that gives us an answer of 0.21. So it's really important for the answer that you give the interpretation of words in words. So does someone want to give us an interpretation for this relative risk? Muna, go ahead.
Could it be that people who went to the like people who got the ICP were more by 0.21 times likely? No, people who did not get people who got the ICP were more 0.21 times likely to get measles.
Is it 0.21 times more likely? Is
less than
that
1.
what you said? Yeah, so we'd say
So
less
it's actually
likely, right?
here.
Yeah, so we'd say less likely. So we're 0.21 times less likely to develop measles than those who did not receive ICP. And those in the group without ICP. So that's how you put it into words. What if you wanted, if it didn't make sense to you to say it as less likely, if you wanted to change it into something that's more likely? Do you know the trick to do that? Pardis?
Actually, that was my question. I was going to say, can you do 1 minus 0.1 and do it as percentage?
So yeah, we could. I think those get a little more complicated. That I'm asking more about just switching it around so we could say more likely. You can actually inverse this, and it's really the same thing. Because we could also say relative risk equals the CI in the unexposed divided by the CI of the exposed. So we could flip it around too. So then the relative risk would be 15 over 95 divided by 3 over 92. So then you could say people in the non-ICP group are 4.84 times more likely to develop measles than those in the group with ICP. So you can actually flip it around and say it the other way. It's just another way of doing it. So that 2x2 table that we created, it's really important to do that for all your measures of association, for risk difference and your population risk difference. You want to make sure that you get that 2x2 table right. So remember, we're only putting in new cases and the total population at risk. We had groups of 100, but we didn't put in 100 for our total population. We put in that total population at risk. So remember that when you do the 2x2 table. And as long as you do that, I think all of your measures of association, as long as you follow the formulas, you should be fine with. Okay, any questions about those? You guys did a great job. Thanks for all the participation. Yeah, Michael.
So on that last one, is it correct to say that the patient who got the vaccination, they have like a 79% protection compared to the other group, or that's not something we could...
So we weren't really looking at the effectiveness of the vaccine. We were looking at the effectiveness of the infection control.
Okay, thank you.
Tracy.
Hi, I just want to clarify, like, you guys get the 80, is that you get it from, like, so 100 minus 15 new cases and the 5 that were vaccinated and also had get measles at the beginning of the study, right?
Yeah, so you could also look at it as the total population minus the 15 that had measles. But what you said is also correct. So we just started there with the total population at risk of 95 and subtracted 15. So you could start with 100 and subtract the 15 who got measles and the 5 that weren't at risk. You can't, if you use percentage, you got to make sure that you do the math right. You couldn't just say 21% less likely. No, that would not be correct. I think there was an example in the slide deck on how to do the percent less. I think it's easier to stick to these percentages, though. I mean, to this way of saying it. Okay, I will save this and post it along with the other document, and the practice midterm will be open over the weekend, and then I'll probably open the midterm shortly after that. And remember, if stuff didn't make sense tonight and you can't make sense of it after listening to the recorded session again, please reach out to me to have a one-on-one webinar or ask some questions in the discussion thread, and I'm sure other students will jump in and help. But the practice midterm is really great because it's just another set of problems to work through, and that's really how you learn this, is working through those problems. So you're welcome for clarifying things. Thank you guys for giving us a problem that really helped to clarify all the issues too. So you guys are really thinking because you came up with a really good problem that answered all your questions. So good job. All right. Oh yeah, Muna.
I'm sorry, I just had one last question. So when they were asking about the percentages, I think what they meant, and or like what I was also looking into, was when we do like 1 minus 0.21, which would be 0.79. So it would be like people who went to ICP or people who didn't get the ICP, where 79% now had 79% increased risk of measles. Is this how it is?
So I'm going to pull up that slide. And I think people get really confused with this one. So I mean, my advice is to just stick with how I showed it. So here, can you guys see that slide? Yeah, so here it's an increased risk. So you can say the 60% increased risk. So the 1.6 minus. So you could do the 0.27 or whatever it was minus 1 to get the decreased risk because it's negative. Or you could take the one that we flipped if you wanted to say increased risk. But again, I think sticking with the 2 times likely, 1.6 times less likely, or 1.6 times as likely, or the 0.5 times or less likely, that's probably the easier way to do it. Okay, any other questions? Okay, great. I'll see you guys next week. Good night.